In this video, we are going to discuss MicroBlaze soft processor core. MicroBlaze is a soft RISC processor core that uses a 32-bit address and data bus architecture. It has a 32-bit instruction word with 3 operands and 2 addressing modes. Each of the 32 registers is 32 bits wide. It has a programmable pipeline stage with a choice of 3 or 5 stages. MicroBlaze also uses a big endian format. Now, MicroBlaze uses a full Howard architecture, which means that it has a separate bus for address and data lines. It uses the PLB V46 bus standard. The local memory bus, commonly called the LMB, is a Xilinx bus format. It is designed to provide address and data information to MicroBlaze. MicroBlaze also has a feature called Fast Simplex Links, which is designed to act as a dedicated, unidirectional, point-to-point data streaming interface. It also supports the cache link port for instruction and data caching of the contents from an off-chip memory component. MicroBlaze has an ALU that can be optimized to use the dedicated DSP slice in its construction. It also has an optional floating point unit that supports common arithmetic functions. MicroBlaze also has a program counter, instruction decode, and optional cache functionality. One of the benefits of MicroBlaze being a soft processor core is that you only get the functionality you want and don't get the functionality you don't need. That saves FPGA resources and helps you improve the embedded system speed. In this diagram, all the resources that are optional are shown in grey. In this case, the optional components are the iCache on the left, the data cache on the right, the memory management unit on top, as well as the resources included as a part of the ALU: barrel shift, multiplier, divider, and FPU. All MicroBlaze instructions take one clock cycle except those listed here: load and store, multiply, and branches. The performance shown in the middle of the slide is for the fastest speed grade available, with a 5-stage performance setting. Top speed is 307 MHz with a Vertex 6 device. Likewise, when you choose to have MicroBlaze optimized for area, the size of the core gets much smaller, seen here at the bottom of the slide. In this case, the core has been optimized for minimal resources, and we can see that size is about a third smaller than when the core has been speed optimized. Memory architecture. MicroBlaze is implemented with a Howard memory architecture. Instruction and data accesses are done in separate address spaces. Each address space has a 32-bit range, that is, handles up to 4 GB of instructions and data memory respectively. Both instruction and data interfaces of MicroBlaze are 32 bits wide and use big endian bit reversed format. MicroBlaze supports word, half word, and byte accesses to data memory. MicroBlaze does not separate data accesses to input-output and memory. It uses memory-mapped input-output. The processor has up to 3 interfaces for memory accesses: local memory bus, processor local bus, Xilinx cache link. Virtual memory management. Programs running on MicroBlaze use effective addresses to access a flat 4 GB address space. The processor can interpret this address space in one of 2 ways, depending on the translation mode. In real mode, effective addresses are used to directly access physical memory. In virtual mode, effective addresses are translated into physical addresses by the virtual memory management hardware in the processor. Virtual mode provides system software with the ability to relocate programs and data anywhere in the physical address space. System software can move inactive programs and data out of physical memory when space is required by active programs and data. Relocation can make it appear to a program that more memory exists than is actually implemented by the system. This frees the programmer from working within the limits imposed by the amount of physical memory present in a system. Registers. There are 32-bit general purpose registers numbered R0 through R31 and up to 18 32-bit special purpose registers depending on configured options. Some of the special purpose registers of MicroBlaze are listed here. These include program counter, machine status register, exception address register, and so on. Pipeline architecture. MicroBlaze instruction execution is pipeline. For most instructions, each stage takes one clock cycle to complete. Consequently, the number of clock cycles necessary for a specific instruction to complete is equal to the number of pipeline stages, and one instruction is completed on every cycle. A few instructions require multiple clock cycles in the execute stage to complete. This is achieved by stalling the pipeline. While the pipeline is stalled by a multi-cycle instruction in the execution stage, the prefetch buffer continues to load sequential instructions. When the pipeline resumes execution, the fetch stage can load new instructions directly from the prefetch buffer instead of waiting for the instruction memory access to complete. Three-stage pipeline. When area optimization is enabled, the pipeline is divided into 3 stages to minimize hardware costs: fetch, decode, and execute. When area optimization is disabled, the pipeline is divided into 5 stages to maximize performance: fetch, decode, execute, access memory, and write back. The MicroBlaze instruction set architecture consists of notation, formats, and instructions. The notations are more or less similar to the arithmetic symbols like cross sign for multiplication, etc. Formats. MicroBlaze uses 2 instruction formats, type A and type B. Type A is used for register-register instructions. It contains the opcode, 1 destination register, and 2 source registers. Type B is used for register immediate instruction. It contains the opcode, 1 destination register, 1 source register, and a source 16-bit immediate value. We have enlisted a few instructions here, but since the entire instruction set cannot be covered in this video, you can visit the Xilinx official website and refer to the MicroBlaze reference guide. Thank you.